Hi all, welcome back. Welcome back to one more vlog on System Verilog coding series. In today's video, we are going to see about fork join coding. In today's video, I'll be first showing you some codes. Try to estimate the output of those codes and ping me in the comment box. Okay, before watching this full video. Right. So the first question of this video is which fork join semantic is best for initiating multiple threads in a non-blocking manner. Basically, you all know that fork join was introduced in order to process multiple threads at the same time. Is it or not? So, in this way, which fork join semantic is best for non-blocking manner of uh, initiating the multiple threads at a time? Okay, so this is our first question. And then second question is try to estimate the output of this following code. Okay, so this is the code, right? So this entire code, you just what you do is you just pause this video and try to estimate the outputs of this code. Let us see how many of you will me the correct answer, so that you will also feel confident on whether you could easily analyze the codes on fork join, because when you enter into, many of you have this one doubt, like where we basically use the fork join in real time. So when you are developing the test bench environment, okay, when you are processing, you will be having various functions, is it or not? So various processes, basically various methods. So all these various methods you will be initiating in within this fork join only when you are writing the test bench development code. Okay, we'll see that I have already explained the test bench architecture code of System Verilog, like a basic code on adder for System Verilog test bench. I'll link that in the description box. You can go there and check it out. There you can actually see where we have used this fork join, right? So this is my first question. Try to answer this. Okay, I'll be explaining it in the uh, like in few seconds I'll be explaining it, but this is my first question. Okay, try to answer this in the comment box. Please give me the answer for this particular question. Okay, and then your second question is this one. Okay, so this is the second question, which is fork join any. Okay, so within the fork join any I'm having some statements, whereas within the outside the fork join any also I'm having some statements. So try to estimate this and give me the output, like which statement will be displayed first and which statement will be displayed next. Okay, so this is my second question. And then coming to my third question, this is my third question, which is nested fork join. Okay, if you see this particular statement, then this is the output of this statement is somewhat different when than you imagine. So try to estimate the output of this particular code, which is nested fork join. Okay, so this is my third question, right? So try to estimate the output of these three codes. In the upcoming sessions I'll be giving some more uh, questions on this fork join, right? So coming to the answers of this question, the first question is which fork join semantic is best for initiating multiple threads in non-blocking manner. Basically when we go for non-blocking manner, we'll be choosing either fork join any or fork join none. Why is it? Because fork join is a blocking manner when it comes to the initiating multiple threads, whereas fork join any and fork join none, those two are non-blocking manner, in a non-blocking manner. So basically you will be using either um, this fork join any or fork join none, right? Now coming to your second question, which is this particular thing, which is the statement. So the first, this statement will be displayed. Okay, after initial begin, the first statement is this, so this will be displayed. Okay, and then it will be the simulator will be entering the fork join block. So within the fork join block, if you see here, I am having two processes. Okay, so within the two processes, here this is at 0 time and this is at 5 time units of delay. Again this is at 0 time and this is at 20 time units of delay, right? So now when it comes to execution, what will happen? This will be executing at 0 time units. So after the execution of this particular statement at 0 time units, process 1 will be starting. Okay, and then again it will be, since here if you see, since this is fork join, so both process will be starting at same time units. So this at 0 time, first this will be executed, and then at the same 0 time process 2 will be started. Both process will be started at same time. Okay, since the execution is parallel in nature. And then after 5 time units process 1 will be finished. Okay, so now after 5 minutes the process 1 is finished. So this entire process is completed at 5 time units of delay. Okay, then what happens, since this is fork join any, until all the statements within the fork join, since this is fork join, until all the statements within the fork join are executed, the simulator won't be coming out of this fork join block. So again at 20 time units process 2 will be finished. After process 2 will be finished at 20 time units, then the output will be coming out of this, and then at again 20 time units only, since there is no time delay given. So after 20 time units, at the same 20 time units, fork join outside will be printed. Okay, outside fork join will be printed. Right, now if you see the same thing with fork join any, now what happens in fork join any, if at least one of the process will be completed, means the process will be coming out of the block. So what happens, everything will be same basically. At 0 process 1 will be executed, at 0 process 2 will be executed, and at 5 process 1 will be finished. So since process 1 will be finished at 5 time units of delay, then what happens, so since at least one of the process is completed, the simulator will be coming out of the thing. Now what happens, at 5 time units only, okay, outside fork join will also be printed. Right, outside fork join is printed, and then after this at 20 time units fork join process 2 will be finished. Okay, clear? So this is for fork join any 0 0 5 5 20. This is for fork join any. If it is fork join, this is 0 0 5 20 20. Okay, right, now if it is fork join none, then what happens, if it is fork join none means, so you all know that if it is fork join none, even though simulator enters, there is no condition that it should execute at least one. Okay, it doesn't enter into the fork join none. Fork join none means the simulator doesn't go into the fork join none, and it will be executing the outside statements. So at 0 first this will be displayed, and then again at 0 the outside fork join will also be displayed, and then the remaining things according to their time delays, the remaining things will be displayed like 0 0 5 and 20. Okay, right, so what will be the output for this, 0 0. Okay, what is this 0, this 0 is this particular thing, and then again after that this 0 is for outside fork join, and then 0 process 1 started, 0 process 2 started, and then at 5 process 1 finished, at 20 process 2 is finished. Okay, according to the time units that it is given, the execution will be done. Right, so this is about the fork join any, and fork join none on a single example. Okay, so try to execute this on the EDA playground so that you will get an idea on what I am telling about. Right, now the coming to the next one, which is, okay, if you see this is fork join any, and then within the fork join any I am having three statements which are ABC, and then outside the fork join any I am having D. Now if within the fork join any, if you see here, I am having three display statements, where one I didn't mention any any delay. For the first statement I have mentioned #1 delay, and for third statement I have mentioned #0 delay. Again outside the fork join any I didn't mention any delays. Now coming to the fork join any statement, since this is fork join any, then what happens, at least one of the statements should be displayed. So since it is no display is given, so that is why A will be displayed first. Why? Because what is the difference between no zero no zero delay and zero delay? No zero delay will be executing in the active region, whereas zero delay will be executed in the inactive region, zero delay statements. So that is why first the no zero values, that means no delay will values will be executed first, and then the simulator will be choosing the zero delay statements. So first A will be displayed. Since at least one of the statement is displayed, so obviously the simulator will be going out of this particular fork join any block, and then the D will be displayed. So both will be displayed as zero time delay only. Then according to inactive region, the C should be displayed, which is zero time delay. So both of these three will be at zero time delay only. But how the order should be, since if we want to decide if the order should be in this manner, then we choose this fork join any. Okay, A, D, C. Okay, and then coming to the next, which is B. Okay, so in this, which is at one time delay. Clear? So in this way, now try to estimate the same output for fork join none. If I am just mentioning it as join none, then try to estimate the output and link me in the comment box. Right, now the third one is nested time delay, which is very important in system verilog, because recently I have seen many of the companies interview questions on LinkedIn. So when it comes to fork join, many questions are from this nested blocks only. Okay, so okay, so before going into this video, if you like this video, please consider subscribing my channel and hit on the notification bell also. And also, please do share this video to all the VLSI aspirants who are also interested in design and verification domain courses like Verilog, System Verilog, and UVM. That is all. Thank you all.